Hello friends, this is Jim with Science Talk, and I want to discuss with you human impact on oceans. Human activity leaves diminished oceans. Humankind has already disturbed or degraded 6/7 of the planet, with diminished oceans the result. And that is before the impact of climate change. Thanks to human activity, the wilderness of the worldwide seas, oceans, have drastically shrunk, decreased. Earth is as you all know, Earth is a water world. And I've been one of those people that say we should rename the planet, not call it Earth, call it Oceanus. Because, right, 70% of it is covered by the ocean. 87% of the water world has been to some degree fouled, polluted, poisoned, impoverished by the actions of humans, one terrestrial mammal. Only 13% of the high seas can now be considered true wilderness. This is a new survey. And let's not forget how overfishing, the impact of overfishing affecting food webs and chains. For example, because of what we've done with the sharks and the important ground fish and pelagic fish, we're now seeing an explosion of jellyfish in the ocean. Terrestrial life is basically, it's kind of thinly spread, but it can be found in an altitude bounded by tree roots and canopy, right? Very thin layer. Yeah, birds can fly high, but they still got to come down. Right? All the ocean is habitable, but we have organisms in the deep sea, on the deep sea vents, for example. From tidal pools to the abysmal plain. And even with the dead organisms that sink down, you get a whale that dies of natural causes. It sinks. Wherever it hits on the ocean bottom, ring the dinner bell. Organisms will feast on that. The ocean is the home to the greatest mountain chain on the planet. Mid-oceanic ridge system. It's a continuous. Go look at the bathymetric maps of the planet. The ocean also has the tallest mountains. Right? The Hawaiian Islands, right? Yeah, above sea level, maybe a couple thousand feet up there, but the whole thing goes right to the ocean floor. It's over 35,000 feet tall. Marianas Trench is, not the trench, the ocean floor where the Hawaiian Islands sit on is shallower than the deepest portion of the trench, but the Marianas Trench is like at 37,000 feet down. It's well over 7 miles. Immense pressure down there. So researchers looked at 16 different kinds of watery environments, ecosystems, and they tested them for 15 different kinds of human impact. Among them, commercial shipping, sediment, fertilizer runoff, overfishing. And they report their findings in the journal Current Biology. And they basically say, yep, humans have left their mark everywhere, and it's not always good. Kendall Jones, who is a researcher at the University of Queensland, Australia, as well as the Wildlife Conservation Society, states, "We were astonished by just how little marine wilderness remains." Right? That's said at the outset. What? Only 13%. Okay. Only 13% remain intact or unspoiled. And we're not even talking about organisms that may live on land but get their living from the sea, and what happens when you decimate their numbers, how that affects the distribution and the diversity and the numbers of organisms in the sea. For example, the great auk, kind of called the penguin of the north. There used to be millions of them. This is up in the Canadian Atlantic region, Atlantic Maritime region. Well, within 100, 200 years, they were all of them are extinct. They were just killed because they had no natural enemies. So guys, Europeans just used to walk right up to them and club them to death. Oh, look at the lovely nutritious eggs and look at the meat here. And they were tall birds, about a meter or so high, and they've been wiped out. Well, they did what? They fed on fish in the sea. So now you change the dynamics of the ecosystem and the balance of things. You overfish, right? And then what happens? Again, you change the dynamic. For example, if you have a mammal that feeds on a certain type of fish or types of fish, and those fish are over fish, it has to do what? It's either going to starve or it has to switch to eating something else that may not be as nutritious. Or you have an orca that feeds on a mammal, a marine mammal, like an otter or something like that, or a seal. And something happens with the seal, because what it feeds on, there's not enough of, so the seal numbers decline. So what do the orcas do? They're going to have to prey switch. Sometimes they're not able to sustain their numbers. You know, the further up the trophic levels you are, if there's a problem with one of the trophic levels below you, you're screwed. So there's all these things going on. You know, and we can measure this by the CPUEs, catch per unit effort. It takes more and more effort to land the same or oftentimes less tonnage than before. So if I, you know, in the past, let's say 40 years ago, I could take my boat, go, you know, 5 miles offshore, run my seine net, and within an hour I land, you know, a ton or so of fish. Okay. Versus maybe today I have to go 20 miles offshore. I have to run my net for a longer period of time, and I land half a ton. I have a decreased catch per unit effort. Right? The distance travel out, how long you deploy the net, be it seine net, trawl net, what have you, all factors in, you know, and as well as what is landed, all factors into the catch per unit effort. And because of overfishing, fishermen have to go further and further to sea for longer and longer time, often not landing the same amount of the problems. So Dr. Jones continues to state, the ocean is immense, covering over 70% of our planet, but we've managed to significantly impact almost all of this vast ecosystem. So, what oceanic areas, wilderness, are still basically intact? It accounts for about 54 million square kilometers, which may sound like a lot, but when you look at the overall surface area, no. So, where is much of this quote-unquote untouched ocean? But keep in mind, there's microplastics there, so that may not even hold now. Arctic, Antarctic, around the more remote Pacific islands. That's it. Hardly any marine wilderness survives along the continental coastlines, basically the continental shelves. This study comes only weeks after a survey of land conservation areas, once again led by researchers from the University of Queensland and Wildlife Conservation Society, found that even those stretches of mountains, savanna, forest, wetland, formally recognized by government as nature reserves or conservation zone, were in many cases significantly disturbed or degraded by human intrusion. The plight of the high seas has been disturbing marine scientists and oceanographers for some time. They have repeatedly warned that human-driven climate change is affecting ocean temperatures and compromising the health of the ecosystem on which, for instance, commercial fisheries depend. And I did a video some time ago where if you really warm up the surface layers of the oceans, you're going to affect how the stratification of the upper layers, how that proceeds, which then affects primary productivity. Now keep in mind, the two key sequence of events, overall scheme of things, for productivity to take place is you need some sort of a mixing event, an overturn of the water column. This mixes in nutrients from below, followed by stratification to stabilize the water column so that the nutrients are locked in place in the upper layers, so then the phytoplanktons have access to it and can do their thing. But if you have a situation where this, and technically we call it a pycnocline, a change in density. Remember, in seawater, the density is determined by not just temperature, but temperature and salt content as well, salinity. So if you start creating a more kind of quasi or even semi or even full-time permanent shallow water pycnocline in the upper layers, you're going to permanently stratify that layer, and typically it's in a photic zone. Photic zone is how deep sunlight can penetrate to the bottom of it. You then don't get this mixing event. You then don't mix in these nutrients that the phytos need. What's going to happen to productivity? It's going to drop off. Right? That's the concern that I have as an oceanographer, and let alone the fact that in the Bering Sea we're seeing a switch from diatoms to coccolithophorids. Diatoms are cold water phytos. Coccoliths are prefer warmer waters. So we're already seeing the regime changes. And guess what? We're seeing effects to at least in the Bering Sea ecosystem. Because coccoliths mean warmer water, there's less productivity because there is a bit more stratification that goes on with less mixing. That's affecting the zooplankton, it affects the fish, then the next fish, etc. We're already seeing it. And don't forget the seabirds that feed on the fish. And the seals. You get the idea. So, and I've been talking about this for some time, that the warmer temperatures will have an adverse, a deleterious effect on oceanic productivity. And in addition to creating this almost permanent shallow water stratification. I mean, there is a permanent pycnocline, but that's like 1,000 meters down or more, depending. But now we're getting shallow water. Human actions have also created dead zones, which is where great tracts of toxic algal growth fed by nutrients from the land, right? Nutrients, the over-fertilization of farmland washes out. You get the nitrates and the phosphates into the river system that flushes out to the sea. And now you basically have what's called eutrophication, and you just get this toxic algal growth, and they just use up so much of the dissolved oxygen in the water that BOD, biological oxygen demand, goes up, and now you're creating dead zones because there's no oxygen for the organisms, your fish, your zooplankton, your invertebrates, whatever. So not only does increasing water temperature decrease the solubility of gases, now you throw in some eutrophication events with toxic algal growth that basically jack up the BOD, and then there's no oxygen from that accord for the organisms. They start dying off. I mean, look at the red tide situation off the coast of Florida. So there's all these impacts. It's a system. You change one thing here, all these possible interactions and other, domino effect events can take place. I've already shared with you how plastic waste is found just about anywhere and everywhere, and the changes in the water chemistry itself, not just the pH, but as I just shared with you in a previous video, dissolving the shells of the organisms. Corals, plankton, other invertebrates, mollusks, and other crustaceans. The Queensland study only looked at those measurable human impacts. The implicit message is that acidification, sea level rise, ocean temperature increase will ultimately affect even those areas of ocean defined as surviving wilderness. In other words, the remaining 13% will also be adversely affected. They're not immune. It's coming for them. And considering how microplastics are already in the Arctic water, it's probably already too late. So, this kind of research that was done here, which is a detailed study, requires meticulous accounting. So, basically, they looked through hundreds and hundreds of studies. They identified the data on which they wanted to concentrate their efforts on, and then they found ways to test their hypotheses. So, in this case here, check the range of distribution of more than 21,000 marine species. So they checked the range and distribution of more than 21,000 marine species, separately considering submarine kelp forests, coastal reefs, warm and temperate zones, deep ocean, polar waters. This is an extensive study. Until you actually undertake one of these things, you probably cannot appreciate the detail and how time-consuming this is. So, kudos to them for doing a study. It's important information, and done quite well. Researchers found that more than 8% of the wilderness was in warm Indo-Pacific. Only 5% of the remaining marine wilderness enjoyed any formal governmental or international protection. Off the coast of Alaska, up in the Beaufort, into the Arctic Ocean, there's no protection there. Trump has just approved drilling, offshore drilling. Good grief, if you thought what happened in the Gulf of Mexico with Deepwater Horizon blowing its lid, imagine a similar spill up in the Arctic with sea ice. You will destroy, it will be catastrophic. You will destroy that ecosystem outright. Polar bears, narwhals, right whales, bowhead whale, boom. You'll just destroy it outright. Dr. Jones states, pristine wilderness areas hold massive levels of biodiversity and endemic species and are some of the last places on Earth where big populations of apex predators are still found. This means the vast majority of marine wilderness could be lost at any time, as improvements in technology allow us to fish deeper and ship farther than ever before. Right, what I was talking about earlier with the CPUE. But also, don't forget, water is moving, it's flowing. You got currents, you got horizontal movements, vertical movement, you got mixing. So eventually, all this shit that's in the waters, and the 87% that's been affected, is going to find its way into 13%, and it probably most likely already has. Thanks to a warming climate, even some places that were once safe due to year-round ice cover can now be fished. In other words, the sea ice is not there. Oh, now we gain access. So the oil companies, no Arctic ice in the summertime. Let's go drill up there. Let's make the situation worse. And don't forget, if you don't have sea ice, you don't have albedo. Albedo is reflective energy back into space. So instead of the long wave radiation being reflected back into space, right? Sunlight comes in as short wave and then is reflected back out as long waves. Comes in the UV, goes out as the IR. Well, now, instead of the ice reflecting that heat energy back to space and cooling things down like it does in Antarctica, so that's a high albedo. Now you got no sea ice. You got open water. Guess what the water does? It absorbs the heat, warming the ocean further. Another reason why the Arctic is warming so much faster. And why, for 3 winters at my house, I've yet to see 40 below. So, bottom line of all of this is that we're screwing up the ocean. We screwed it up big time, and we're screwing up the last few remaining bits of it. Just can't seem to, we do ruin everything we touch, don't we? So, this is alarming news. It's an excellent study, but it provides lessons for us as to what really needs to be done. And every day, more and more, I become less and less optimistic. I become more and more pessimistic that humans will change course. Sad to say. Thank you for your time. Talk soon. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.